Hello everyone, welcome back to another session. In this session we're going to talk about L'Hopital's rule. Using L'Hopital's rule we can find the limits that we were not able to find them before. The limits that become 0 over 0 or infinity over infinity after direct substitution, we can use L'Hopital's rule for them. The way of L'Hopital's rule is like this. We have a function, it's usually fraction. This is why we get 0 over 0 or infinity over infinity. We do derivative of up and derivative of down separately, then we try to do the limit again. If we fail to find the limit again we got 0 over 0 or infinity over infinity. We do derivative again and then we try again to find the limit. Here, there is a very important note. We should always do derivative of up and down separately. Never use quotient rule. When you are using L'Hopital's rule to find a limit, don't do quotient rule. Don't say down power 2, then denominator times derivative of numerator. Never do this. It's derivative of up, derivative of down separately. Then try to do the limit again. You see the answer. Look at this example. In this example, we have sine x over x. The x tends to 0. X tends to 0 for sine x over x. Then if I directly put 0 in place of x, I will get sine 0 over 0. And obviously sine of 0, it's equal to 0. If you don't know, you can use calculator. Sine 0 is equal to 0 over 0. 0 over 0 is indeterminate form. Then what should I do? L'Hopital. L'Hopital is like this. Derivative of up, then derivative of down. Derivative of sine x is equal to cosine x. Derivative of x is equal to 1. Now I got cosine x over 1. Then if I replace x with 0, I will get cosine 0 over 1. Cosine 0 over 1 is like cosine 0. And cosine 0 is equal to 1. So the answer of this limit finally is equal to 1. We have 3 exercises. Question 33, 34, 35. All of them, the question says use L'Hopital's rule. Now, if I put 3 in place of x, it's 2, 3 minus 3 over 3 power 2 minus 9. This is equal to 0 over 0. If I try to rewrite, it will be like 2x minus 3. And down is difference of 2 squares. It's x minus 3, x plus 3. This will cancel out. The answer will be 2 over x plus 3. Now if I replace x with 3, I will get 2 over 6. The limit is 2 over 6, which simplifies to 1 over 3. This is one way. The other way is, since I get 0 over 0, I can directly use L'Hopital's rule. Then using L'Hopital's rule, the derivative of this part, we need to simplify it first. It will be 2x minus 3, then derivative of 2x is 2. That's up. And down is x power 2, derivative of x power 2 is 2x, derivative of 9 is 0. Now if I take limit x tends to 3, then replace x with 3. The answer is 2 over 6, which simplifies to 1 over 3. See the answers? It's the same. Then it's better whenever you see 0 over 0, directly use L'Hopital's rule. Don't waste time. Do it and be fast with it. 34. We have this polynomial over x plus 1. The x tends to negative 1. Don't forget to always check. It's not always 0 over 0. Sometimes it looks like it will be L'Hopital, but after you directly substitute, you see it's not 0 over 0. Now let's check. 2 times negative 1 power 2 minus negative 1 minus 3 all over negative 1 plus 1. Now, you can do this step by calculator. And in calculator, don't do all together. Do up alone, write the answer. Do down alone, write the answer. Then at the end, you see the answer. Negative 1 plus 1 is 0. That's clear. Here, negative 1 power 2 is 1. 1 times 2, 2. Minus minus is plus, so 2 plus 1, 3. 3 minus 3 is 0. Now, since it's 0 over 0, I can use L'Hopital's rule. L'Hopital is derivative of up. Derivative of this term is 4x. Derivative of negative x is negative 1. And derivative of 3 is 0. We don't need to write. Derivative of x down is 1. Derivative of 1 is 0. So this is the derivative of up and down separately. Now, if I do the limit, x tends to negative 1. Replace x with negative 1. It will be 4 times negative 1 minus 1 over 1. 4 times negative 1 is equal to negative 4. Minus 1 is negative 5. So the answer is negative 5 over 1, which is negative 5. This is the answer of question 34. Now we have 35. In question 35, again, if I directly put 3 in place of x, see what will I get? It will be square root 3 plus 1 minus 2 and 3 minus 3. I replaced x with 3 and I get 3 plus 1, 2, square root 2, 3 plus 1, 4, square root 4 is 2, 2 minus 2 is 0 over 0. I got 0 over 0, now let's use L'Hopital's rule. Derivative of square root is 1 over 2 square root x plus 1. Derivative of minus 2 is 0, and down, don't forget where is the big fraction. Down is x minus 3, so it will be 1. So this is the denominator. Now replace x with 3. It will be 1 over, this part will be 4. Square root of 4 is 2. 2 times 2 is 4 as well. Then 1 over 4. Over 1 is nothing, so it's 1 over 4. Or you can make it decimal, 0.25. This is the answer. Now in these limit questions, the question is not mentioning L'Hopital's rule at all. We should know when to use L'Hopital's rule. We use it when we see 0 over 0 or infinity over infinity. Let's look at question 36. If I put 0 here, it's obvious down will be 0. And if I put 2 here, down will be 0, 2 minus 2. And if I put 2 up, 2 power 2, minus 2, minus 2. 2 power 2 is 4. Minus 2, 2. Minus 2 again, it will be 0. So it will be 0 over 0. Now, since it's 0 over 0, I can use L'Hopital's rule. Derivative of up is 2x minus 1. Derivative of down is 1. Now replace x with 2. Limit. X tends to 2. It will be 2 times 2 minus 1. 2 times 2, 4. Minus 1, 3 over 1. The answer is 3. Question 37. 37, same thing. If I put 0 here, down will be 0. And if I put 0 here, it will be square root 4, which is 2. Then 2 minus 2 is 0. So we can use L'Hopital's rule. Using L'Hopital, derivative of up is 1 over 4 minus x squared. 2 here. Don't forget derivative of inside. Derivative of inside is negative 2x. Then this negative 2x will go up next to 1. We can do this. So this is derivative of up. Then let's remove the 1. Yes. Don't forget derivative of square root is 1 over 2 times the square root times the derivative of inside. Derivative of inside is negative 2x, then we write the negative 2x up. So what did I do here? I did only derivative of up so far, so this is the result. Over derivative of down is 1. So when you have multiple fractions together, don't forget to mention that. Where is the big fraction? Where is the main fraction? It's here. Up of this fraction is another fraction. It's okay. Now we replace x with 0. Limit x tends to 0 is down is 1. This up negative 2 times 0 is 0. And this will be 0. 0 power to 0, then down will be 4. Square root of 4 is 2. 2 times 2, 4. 0 divide 4, 0. 0 divide 1, 0. So the answer of this limit is 0. Now question 38. We have ex. Ex is easy because derivative of ex is ex. Integral of ex is ex. Ex is a very easy function, exponential. So limit x tends to 0. If I test, put 0 in place of x, it will be e power 0, which is 1, minus. Put 0 in place of this x, it's 1 minus 0, it will be 1. 1 minus 1 is 0. And down, if I put 0 in place of x, it will be 0 over 0. Now I'm sure I need to use L'Hopital's rule. Now, L'Hopital's rule is derivative of up and derivative of down alone. Derivative of ex is ex. Same thing. This minus, if we give it to inside, it will be negative 1 plus x. Derivative of x is positive 1. So it is plus 1. Over derivative of x down is 1. Now if I replace x with 0, it will be e power 0, which is 1, plus 1, that will be 2. Then the answer is 2 over 1, which is 2. Next question, question 39. Similarly, we test to see if we can get 0 over 0 or infinity over infinity. Let's replace that. Ln of 1 is equal to 0. Ln of 1, 1 power 2 is still 1. Ln of 1 is equal to 0, so up will be 0 over. If I put 1 here, that's 1. 1 minus 1, 0 again. So this is 0 over 0. That's done. Then we need to use L'Hopital. Derivative of ln is like this. We write 1 over whatever is inside the ln times derivative of this. Derivative of x power 2 is 2x. So we can write the 2x up. 2x so it is 2x over x power 2. This is the derivative of up. Of course, there is simplifying. Over x power 2, which is down, becomes 2x. Now, there is simplification. Here in this fraction, x can cancel 1 power of this x. So it will be 2 over x all over x. I can simplify this more, but I don't need to do that. This down is 2x. I don't need to do that. I know I can simplify this way more, but I don't need to do that. Straight away put 1 in place of x, get the answer you need. Your question is not about simplifying expressions. Your question is to find limit. Then replace hx with 1. It will be 2 over 1 over 2 times 1. 2 over 1 is 2. 2 times 1 is 2. So the answer is 1. This is the limit. Now question 39 finished. Let's do 40. If I directly put 0 in place of x in question 40, if I directly put 0 in place of x, this will be sine 0. A times 0 is 0. Sine 0 over sine 0. And sine 0 is 0, so this will be 0 over 0. This will be 0 over 0. Since it becomes 0 over 0, I should use L'Hopital. Using L'Hopital, derivative of sine AX. Derivative of sine is cosine AX times the derivative of inside. Derivative of AX is A. So it's A cosine AX over sine BX. So it will be B cosine BX. When we studied limit, we had this as a rule. Like when x tends to 0, sine AX over sine BX, it will be A over B. We had this rule. And we had an example. We had sine 2x over sine 3x. The result is 2 over 3. Where did this 2 over 3 came from? It came from L'Hopital. Then this is limit x tends to 0. X tends to 0 means replace each x with 0. Now it will be cosine 0. So it's A cosine 0 over B cosine 0. This will be 0. 0 times A is 0. Cosine 0 is 1. Then the final answer is A over B. So we can consider this as a rule. If you see sine x tends to 0, sine any number times x over sine of any other number times x, we can say it will be only the coefficients of the x. Now question 41. This time the limit tends to infinity. If we replace them, it will be 3 times infinity power 2 minus 2 times infinity plus 1 over 2 times infinity power 2 plus 3. Okay, so this will be infinity over infinity. Infinity power 2 minus 2 infinity, that's infinity. And infinity plus 3 is just infinity. So this will be infinity over infinity. This is indeterminate form. Or we can say this will be infinity minus infinity over infinity. Infinity minus infinity is indeterminate form. It's not equal to 0. Be careful of that. This is indeterminate form. Either becomes infinity over infinity in questions, or somehow you see infinity minus infinity. It's not equal to 0. It's indeterminate form. It's indicating that we should use L'Hopital's rule. Now let's do 41. Using L'Hopital, derivative of 3x power 2 is 6x minus derivative of 2x is 2. This is the derivative of up. Derivative of 1 is 0, no need to write. And down is 4x plus 3 is 0. Now the limit tends to infinity if I replace everything with infinity again. By the way, this is not the only way of doing this limit. We can divide up and down everything by x power 2, then replace x with infinity. But this time I want to use L'Hopital's rule. I want to show you that this rule is brilliant. It works all the time when you see 0 over 0, infinity over infinity, infinity minus infinity, any other indeterminate form. Now if I write infinity here, it will be infinity minus 2, which is infinity, and put infinity here, it will be infinity over infinity. This means I should use L'Hopital on this limit as well. Then derivative of 6x is 6, derivative of 4x is 4, then this is the answer of the limit. 6 over 4, that simplifies to 1.5 or 3 over 2. So if after the first derivative the limit is still indeterminate form, we should do derivative again, then do the limit. Question 42, we have something special here. If I replace x with infinity, it will be infinity. And if I replace x with infinity down, it will be infinity as well. So it will be infinity over infinity. Now, normally when you see a question like this, you try to use L'Hopital because it's a good way. Then see what's happening. Derivative of up, which is x, it's 1. Derivative of down will be 2 square root x squared plus 1. And up is derivative of down, derivative of the root, which is 2x. Now, after the first derivative, if I replace every x with infinity, down will be infinity over infinity again. If you look at it, 2 cancels 2. It's the same function. It is again x over square root x squared plus 1. In such cases, L'Hopital is not a good way. We cannot get the answer. We do derivative again we will get the same thing. Then what we do, we need to go back to the old way, divide, since it became infinity over infinity, divide up and down everything by x. This x power 2 is under rule, so we consider this as x. And this is x, so we divide up and down everything by x. So going back to this way, it will be x over x, and down will be x power 2 plus 1 all over x. So I divided up by x, I divided down by x. If I want to send this x inside the square root, the x should become power 2. Now up becomes 1, x over x is 1. If I want to enter this x to the root, it should become power 2. It will look like this, x power 2 over x power 2 plus 1 over x power 2. So these two cancel out each other. So it will be like 1 over square root 1 plus 1 over x power 2. This is how it looks after dividing up and down by x. This way is not L'Hopital rule. This way is not related to derivative. But this is a way of calculating limits when the derivative, when the L'Hopital keeps repeating the function. Some functions are like this. Then when you see after the first derivative, the function looks the same, either entirely looks the same or the function repeats itself in the denominator, then give up on L'Hopital. Go back to this way, divide up and down everything by x. Highest power of x in this function is x power 1. This x power 2 is under square root. It's also considered as x power 1. Now after simplifying the function, I have this. Now I do limit for this. If I do limit for this one, replacing x with infinity, up will be 1. It has no problem. Down will be square root 1, and this part will be 1 over infinity. And 1 over infinity is 0, so it's over 0. Now, 1 plus 0, 1. Square root 1, 1. 1 divide 1 is 1. At the end, the answer of question 42 is 1. And that's how we do it. Such questions are not very common, as you saw. We could solve many questions using L'Hopital, but here we got a case of repeating the function. Then we use the old way, which is divide up and down everything by highest power of x. Question 43. Now in question 43 we have sine pi. Sine pi is equal to 0 and pi minus pi is equal to 0, so we use L'Hopital. It will be cosine x, and down derivative of x is 1. Derivative of pi is 0, we don't need to write, so we have this. Now if we enter pi in cosine, limit x tends to pi for cosine x over 1, cosine pi You can use calculator or you can use pi is 180 degrees. Every time you use sine, cosine, so pi is 180 degrees in calculator. Or you can do it by graph. Cosine of 0 is equal to 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine 270 is 0. Cosine 360 is 1. You can memorize by graph, or in calculator just use pi as 180 degrees, then write cosine 180, press equal, you get the answer. It's equal to -1/1. So the final answer of this limit is -1. Now I have a homework for you. On calculator, how can you calculate cosine 3 pi over 2? And how can you calculate sine 5 pi over 2? How can you do these by calculator? Then this is your homework. Question 43 done. Now let's do question 44. This is the last question of this session. Now, question 44. If we replace x with infinity, it will be ln of infinity, which is equal to infinity. And x power 3, infinity power 3 is also infinity. So this will be infinity over infinity. Now we can use L'Hopital's rule. Derivative of up, ln is like this. Whatever is inside the ln goes down. I know there could be simplifying, power goes to the front and stuff. No, don't waste time on this. The right way, derivative of ln is like this. Whatever is inside the ln goes down. Derivative of this goes up. Derivative of x power 4 is 4x power 3. There is cancelling, it's okay. We will simplify them. Over, that was the derivative of up. Derivative of down x power 3 becomes 3x power 2. Now, this 3x power 2, do not forget, it's over 1. Always, when you work with multiple fractions in the same problem, you need to clearly know that where is the main fraction. It's here. Now, up is fraction, down is another fraction. There is cancelling. I can cancel x power 3 and 3 powers of this power 4. X power 1 is remaining. So it's equal to 4 over x all over, so the equal should be with the main fraction, 4 over x all over 3x power 2 over 1. Don't rush to cancel these. These won't cancel out together. Don't rush. Then what we do, this is like a division problem. For fractions, we need to write them as a multiplication problem. Then we can cancel out the terms. Here, we keep the first fraction as it is. So we call this way KCF. KCF means keep the first fraction. C means change this division to multiplication and then flip the second fraction. This fraction should be flipped, so it becomes 1 over 3x power 2. All right. Now, this is a multiplication problem. I can multiply numerators together and denominators together. 4 times 1 is 4. 3x power 3. Now, this is the function simplified after derivative. Now I can replace x with positive infinity. If I put infinity here, it will be infinity. And 4 over infinity is equal to 0. So the answer of this limit is equal to 0. This is the end of this session. Thank you so much for watching. Stay tuned to see the rest of the book. And don't hesitate to ask any question below. You can comment your questions or you can contact me anyhow. Then these are the sessions. Thank you so much for watching. Stay tuned to see the rest of the book. Bye.